Hello, I'm Kim Kenobi. I'm a statistics lecturer in Aberystwyth University. And today I'm going to present a talk about human interactions with marine mammals in Cardigan Bay. So the Cardigan Bay Marine Wildlife Centre is situated in Newquay, about 3/4 of an hour drive south of Aberystwyth. And pretty much every day between about March and November, a volunteer from the Wildlife Centre goes out on one of the dolphin watching boats. They record sightings of dolphins, porpoises, and Atlantic grey seals, along with quite a range of different environmental variables. The data set that I'm using for today's talk was gathered between 2005 and 2015. So let's just have a look at what the data set looks like. And it's split into two different data sets, one of which is called the effort data, which we're looking at here, and the next slide is about the sightings data. So I've just shown a subset of the columns here to give you some idea of what the effort data looks like. So we have the date, we have the effort type, whether it was a dedicated search, which is a 4-hour trip, or a casual watch, which is one of the tourist trips for about 2 hours. The sea state, with higher numbers corresponding to a rougher sea. What was the swell like? An ID which links it to any sightings, the visibility, whether there was any precipitation, and then codes for the boats that were seen, other boats that were seen while the tourist boat was out. So in that example, MB stands for motorboat, VPB stands for visitor passenger boat, and we'll focus a bit on that boating column in this talk. And then we've also got the sightings data. So we've got the time and the position in terms of latitude and longitude of any sightings, along with the species. So BND is bottlenose dolphin, HP is harbour porpoise, and Atlantic grey seal would be AGS. And then there's a bit of an age breakdown, whether it's adults or juveniles or newborns. We're going to focus on the following research questions. So in terms of day, how does the time of day affect sightings? Similarly for year, how does the probability of sightings vary through the year? For boats, does human activity in terms of other boat sightings affect the probability of seeing dolphins or porpoises? And finally, are there interactions between dolphins and harbour porpoises in terms of sightings? So we're talking in terms of probabilities here, and an appropriate statistical modelling framework is something called generalised linear modelling, and in particular we're going to look at logistic regression. So what we've got in this equation, on the left-hand side, PI is the probability of a sighting under a particular set of conditions, and when we do log of PI over 1 minus PI, that's called the log odds of a sighting. And then on the right-hand side, we've got a linear combination of the explanatory variables, including beta naught, which is an intercept term. So xji is the value of the jth explanatory variable for that particular set of conditions. The first model we're going to consider is about dolphins and boating activity. So this PI on the left-hand side is the probability of seeing a dolphin under a particular set of conditions. So the variables that we're including, we've got boats yes, no, which is a binary variable. So it's a 1 if other boats were seen on a particular trip, and a 0 if no other boats were seen. And then we've got time of day, day of year, and day of year squared. It turns out that we need a quadratic relationship with the day of year to effectively model the relationship. All of the coefficients are highly significant in this model. So let's have a look visually about what we get out of this first model. So here we've got 4 graphs where from top left reading across through to bottom right, we've got early morning, late morning, early afternoon and late afternoon. On the x-axis we have the day of the year. It ranges from 100 to 300 here, so round about March, April time through to October, November. And on the y-axis, we're plotting the log odds of a dolphin sighting. In each graph, we can see that there's a peak in terms of log odds of dolphin sighting towards the middle of the year, around about day 220, so maybe sometime in July, with a tail off both at the beginning of the year and the end of the year. And then we can also see that the line corresponding to when boats are seen is above the line for when there were no boats seen. So interestingly, this is suggesting that when boats were seen, you were more likely to see dolphins. But I'll comment on that a little bit later. The final thing I want to comment on these sets of graphs is that as we go across from early morning to late afternoon, the lines are moving downwards. So that's suggesting that you're more likely to see dolphins earlier on in the day, and as the day gets later, the log odds of seeing a dolphin gets less. So I've just put this on a slide that's summarizing what I've just said. In terms of day, there's a general decrease in the probability of dolphin sightings as the day progresses. In terms of the day of the year, there's the probability of dolphin sightings increases from the beginning of the year to about day 200 or day 220, and then decreases again. And in terms of boats, we need to note here there's more boating activity in general when there are more dolphin sightings. There's better weather, and if people think it's likely they're going to see dolphins, they're likely to be out in their boats. This relationship should not be interpreted as the boat activity increasing the probability of the sighting. It's because there are sort of hidden variables in terms of better weather that's not being incorporated in this model. Okay, let's see what happens when we model the probability of a porpoise sighting. Well, here we get a bit of a different picture. So in this case, the PI on the left-hand side of the equation is the probability of a porpoise sighting under particular environmental conditions. So we've got the log odds of a porpoise sighting on the left-hand side. So we start with the same variables, a binary variable for the boats, the time, the day of the year, and the day of the year squared. But in this case, the modelling showed that the cubic term, day of year cubed, and also the quartic term, day of year to the power of 4, were also significant. So we've got a bit more flexibility with that function that comes out here. We'll see that on the next slide. Note that the higher powers of the day of year are now significant. So here's a visual summary of this model 2, a similar sort of structure to what we saw before. Again, we've got 4 graphs, early morning, early afternoon, late afternoon. As before, we have day of year on the x-axis. This time it's the log odds of porpoise sighting on the y-axis. And again, we've got 2 lines on each graph, one corresponding to no other boats seen, and one corresponding to the presence of other boats. And what we see in the relationship here is that the probability of seeing a porpoise is higher at the beginning of the year and the end of the year, and there's a dip in the middle, but you have a bulge round about day 200, so sort of end of June, July, that sort of time. So we've got these more flexible relationships because we've got the cubic term and the quartic term. If we look at the lines for one of these graphs, so suppose we focus on the early morning, we see that when there were no boats around, the line was higher. The log odds of seeing a porpoise was higher than when there were boats around. But if we compare the 4 graphs moving through the day, there's not really any change in the positions of those graphs. So there's less evidence of a pattern in terms of a diurnal relationship with porpoise sightings. So here we've got that in words. In terms of the day, there's less evidence of a change in the probability of a porpoise sightings through the day than for the dolphins. This relationship in terms of the day of the year, porpoises are generally seen less in the middle of the year, although there's a bit of a bulge around day 200. And here, the relationship with the boating variable is that if there are other boats around, it seems to make porpoise sightings less likely, in contrast to what we saw for the dolphins. And then finally, what we're going to do is just have a quick look at the sort of interactions between the dolphins and the porpoises. And the way we're going to do that is to have the log odds of a dolphin sighting on the left-hand side some familiar variables on the right-hand side, the binary boat variable, the time of day, the day of year, the quadratic term for day of year. The cubic term is also significant, but not the quartic term in this case. And then I've got this extra variable, porpoise yes, no, which is a binary variable saying, were any porpoises seen on that boat trip when the dolphins were seen? So we've got a slightly more complicated graph now. So the top row going across from early morning through to late afternoon corresponds to there being no porpoises around. And the bottom row corresponds to the presence of porpoises, as well as the dolphins. Same x-axis, day of year, and the y-axis is the log odds of the dolphin sighting. So what do we notice here? Well, one thing to notice is that the graphs have leveled off. So it starts off low. Early in the year, the probability of a dolphin sighting is low. But in this case, the model levels off because of the presence of that cubic term. So it's a different sort of setup to what we had before. When boats are seen, again, the log odds of dolphin sighting is higher for all of those graphs. And then the final thing to notice is that if we look across the first row, we can see that as the day progresses, the log odds of seeing a dolphin is decreasing, similarly for when there are porpoises. But the decrease when there are porpoises is less than the decreases when there are no porpoises. So there's some evidence here that dolphins and porpoises are likely to be seen together. So here's the same thing in words. So in terms of the day, there's a decrease in the probability of dolphin sightings throughout the day, as we've seen before, but a less steep decrease when porpoises are present. So in terms of the day of the year, there's a leveling off of the probability of dolphin sightings later in the year. That's because the cubic term ends up as being significant here. And then in terms of boating activity, as before, in general, more boats are present when dolphin sightings are likely. Exactly the same argument as what I said before. This is not to be interpreted as a causal relationship here. So what have we said? Let's make some overall observations about these models. The first thing to note, other boats are more likely to be around when dolphins are sighted. There's better weather and people might have a tendency to go out if they know it's likely that dolphins are being sighted. In terms of the porpoises, there was more porpoise sighting activity when there were no other boats around, which may be due to the time of year. So we had more porpoise sightings at the beginning and the end of the year, and so therefore there were fewer boats around in March and October compared to the summer. Dolphins are most common in the middle of the year. Porpoise sightings are generally less common in the middle of the year, but there's a bulge around day 200, maybe July. Some evidence of dolphin and porpoise sightings occurring together, and dolphin sightings are less likely later in the day, whereas for porpoises, there's no real evidence of a particular diurnal pattern in terms of their sightings. Thank you for listening.